Only 2. All right, we'll start with the easiest. The first one is called a difference, and you'll see we've done this in the box. It still works in the box, but it's a little shortcut. You haven't seen it yet.
Right, and we're moving on to something else.
All right, difference of 2 squares. Tell me what difference means. Subtract, somebody says subtract. Difference in math.
Oh, subtracting.
Subtracting, right?
Yes, sir.
Tell me what squares are, if not geometrically, but algebraically. Huh?
A number
As in times itself, right? So I'm looking for 2 numbers that are perfect squares, like that list of orange numbers we had up here the whole time.
It's on this side now.
It's on the other side of the board now. Separated by a subtraction sign. So maybe 4x squared minus 9. I think this was one of the ones from your homework.
Yeah.
Okay. It's asked me to factor it. There's only 2 pieces there. There's not a middle term. Instead of going through to put it in the box, if I recognize that that is a difference of 2 squares, it is super easy to factor.
Okay.
You take the square root of the first. In other words, what times itself twice gives you 4x squared? 2x.
Good job.
What times itself gives you 9? You do 1 minus and 1 plus, and it's factored.
That's it?
That's it.
I don't like it.
I don't like it.
So why does this go from this? It goes from this easy, from that difficult. It goes to this.
Because everything can't be done this way. This is a shortcut for certain kinds, but you could always still do it the other way.
So will this work for all the ones that look like this?
All the ones that look like this.
Wait, so all the ones that have like
Just 2, yeah.
2 that are perfect squares and a minus. Now, be
If they're
careful.
not perfect squares, then we have to do it the other way.
Yeah. Now, be careful, guys, because this does not factor that way. If there's a plus in the middle, it does not work. It has to be a
Nothing
minus.
works if there's a plus in the middle.
Well, remember whenever we were talking about we added the 0x in the middle? So 4x squared plus 0x minus 9. This tells me that the signs are going to be mixed, right? And they have to add to 0. Well, if I changed it to a plus on the end and you had to have the same signs, nothing adds to 0 with the same sign. So that's why it doesn't work.
So it only works if the 2 squares are perfect squares. I mean,
Yes,
2 numbers are
perfect squares.
and if there's a
Minus in the middle.
Okay.
So look at these and you tell me yes or no, are they a difference of 2 squares? And if they are, we're going to factor them.
Yep. What? You asked a question.
We didn't even get the question.
No, yep, it is. Not working together.
Miss McKee, how can you get frustrated because I asked a question? I'm just saying.
Because she keeps blurting out in the middle of class. She's really trying to focus, young guy. Because I don't know this. You might know this, but I don't.
All right, look at this. All right, look at the first one. Let's ask, guys, y'all want to be able to sit together if y'all can't quit talking. Let's look at the first one. Is it a difference of 2 squares if you were asked to factor this?
Yep.
Yes. How do you know?
Because you got the plus sign.
All right, no, we're looking at the first one. Is this a perfect square?
Yes.
You know that because what times itself gives you x squared?
1x. 1x.
How about 25?
5.
Positive negative 5.
Is there a minus sign in the middle?
Yes. So it'd be negative 5.
So how would it factor?
X plus 5 and then x minus 5.
Yeah, tell them. Again.
It's easy.
Yes?
Yes.
How about the second one? Is it? Why?
Because it got a plus sign.
What if I change this to that?
Yes.
It is now?
Yes.
How would it factor?
3x.
3/8.
Look at that boy in the white back there. I hear you, boy.
All right. That's the easy pattern. Now I'm going to show you the little bit harder pattern.
Oh, Lord.
I barely understand the easy.
All right. Okay. Here's the next pattern. All right. This one is a little bit more difficult.
What is that? Trinomial.
Guys, listen. Math doesn't get easier, okay? This is a challenge. It's always going to be a challenge, okay? Accept it and move on, and let's stop whining about it. We're always going to learn new stuff. You're going to have to study it, and you're going to have to work for it, okay? Perfect square trinomial. No, because every time I put something new, everybody's like, oh my God, we're learning something else.
But it could be easy.
All right, perfect square trinomial. Trinomial means 3 pieces. We've already established what perfect square means.
Yes.
Stay with me before you shut down on this.
Shut down.
If I have a trinomial that has 3 pieces, okay? I know, I don't even have patience for that. If I have a trinomial that has 3 pieces, okay? If the second sign is a plus,
Yes.
okay? Criteria number 1.
The third side, the first side is a
The
plus.
second sign is a plus. The 2 ends are perfect squares. That's criteria number 2. This is a perfect square, and this is a perfect square.
Yes.
Okay?
They have to be.
They have to be perfect squares. This is one of those things where you have to go through a mental check and say, does it meet these 3 criteria in order to be a perfect square trinomial? And unfortunately, yes, this will go in the box and you can always factor it a different way, but we're going to get to something in the next couple sections where you're going to have to be able to work with a perfect square trinomial. All right, here's what has to happen, and I'm going to put some numbers in here for you. This is like your standard form of your quadratic equation, okay? ax squared, bx, and c. Those 2 ends, do we agree, are both perfect squares?
Yes.
Okay. The middle term, here's where it gets hard. You have to check to make sure that the middle term, what color have I got? Okay.
It's a negative.
If you take the square root of the first one, okay?
Oh, man.
So the square root of the first perfect square and the square root of the second perfect square. So in this case, what's the square root of the first?
X.
1x. What's the square root of the last?
5.
5. If you multiply those together and double it,
You get 25x squared.
double it,
Oh, you mean double it? Like, it's 10x.
10x. That has to be what sits in the middle.
Oh, wait a minute.
That's
So
not
we-
hard.
We have to find the middle.
No,
No, that makes sense.
you have to recognize, is it or is it not a perfect square trinomial?
So that's the
No, I get that.
questions.
So all that's going to
So Miss Wilson does a little dance. I'm not going to dance.
Can you dance, please?
No.
Can you get Miss Wilson to
But you
name
do, she's not here today. You do square, 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 multiply, and double. You have to remember that. It's the square dance. Square, square, multiply, and double. What? If it's a perfect square trinomial, yes, it has to be.
So what's the point?
I'm fixing to show you. I'm fixing to show you. It's going to factor easy.
Square, square, multiply, and double.
Square, square, multiply, and double. Because that's the hardest thing to remember about it is that middle term. Yes.
Was the dance a square dance?
Yes, it was. Okay,
Like you just go so far to degrade yourself.
so I haven't told you anything about this sign. This sign can be plus or minus. It doesn't matter, okay? That's going to impact how it factors. So now let me show you why we identify it as a perfect square trinomial, okay? If you can identify it, that's all well and good. But the reason we identify it is because it's a super easy factor. And we actually did one of these from your homework that we'll go back and look at in just a second. So we have established that x squared plus 10x plus 25 or x squared minus 10x plus 25 are both perfect square trinomials. To factor it, you take the square root of the first sign, and the square root of the last, and you put a squared on the outside and it's factored. Yep.
Where did you get the 5?
With me? All right, watch. Square root of the first sign, square root of the last, square.
Okay.
Okay? We did this, we did it in the box earlier. I think it was like a 4x squared on the front and a 9 on the end. And I told you you could rewrite it with the squared or you could write both of them out. It's an easy factor, but you have to be able to recognize it.
So this is basically just another
Another what?
way to solve what we're looking
Correct. It's another way to factor. She always walks out at the most inopportune times
Cool.
to go to the bathroom. Okay. Let me give you a couple of them, and I want you to tell me yes or no. Is it or is it not? We're done. Is it or is it not a perfect square trinomial? Let me give you a few.
It's the same thing we were just doing?
Yep.
So we're gonna get a problem with nothing in the middle.
I'm thinking things through in my head as I put them up here.
Yes. That is, you can do the little thing.
Think about it before you answer.
We just did the same thing we did on the last one.
I want you to tell me, is it a perfect square trinomial? If it is a perfect square trinomial, how does it factor? If it's not, what can we change to make it a perfect square trinomial? Okay, so think about it, write it down, don't blurt it out just yet. If they can, yeah, factor them. Is the first one a perfect square trinomial or nah? Okay, let's walk through our 3 stipulations here. Number 1 is what?
Factor. 25.
Plus sign.
Number 2, yeah, it's both number 2.
Both of these are perfect squares. Does it square dance is the question.
What's square dance?
If you do the square, multiply and double.
I got it's 2x and 5x.
It's 2x. This is 5. If you multiply those together, you get what? 10x. But it's not square, square, multiply. It's square, square,
Multiply double.
multiply, and double.
So if you get 10, then that'll be double and you'll get 20.
No, 2 times 5.
Oh, 2
Yeah, you'd get 20, right. Is that what's in the middle?
No.
No. So it's not a perfect square trinomial.
Oh.
You see?
No.
Yeah, I see. But just finish working it. Finish working it and like show us how it's not. I see where you're coming from in my head.
Okay, so if I multiply these together, I get 10x.
Yeah.
But I must double 10x to get what's in the middle.
So if it's not what's in the middle, it's wrong.
Correct. So it's not a PST.
Not a PST.
That's all we would write on the test.
Yes. Okay, now, what can I change to make it a PST?
The plus sign.
The plus sign. Look at it. What did you say it had to do?
You could change the 4 or the middle one.
You could change the 4 or the middle one, right? If the middle one was what, then it would work? 20. So if this was 4x squared minus 20x plus 25, it's now a perfect square trinomial. Do you agree? How does it factor? This is the easy part. Identifying it is the hard. 2x, the first sign,
Minus 20 minus 5.
squared.
Well, I'm so confused. I understand what you do.
What if she made it so where it could be PS2?
Because if you do the math with that, it'll equal.
If you were to multiply that back out, it would come back out. If you were to put this in the box,
It will come out of that.
and let's look.
So when you factor it in, you don't pay attention to the middle part anymore.
What?
If it's a perfect square trinomial. What you're using the middle part for is simply to identify it as a PST. Look, let's do this and let me show you because I think this will clear it up. Pay attention. If I take what's in blue and put it in the box, both signs are going to be the same. Tell me what multiplies to 100x squared but adds to 20.
Wait, what?
10. 10 times
10 times 10, right? 10 times 10 is 100. 10 plus 10 is 20.
That's a
Ty, you're so
negative. That's a
smart.
negative 20.
But they're both same signs, right? Same signs. So same signs, I don't have to worry about the signs. All right, watch what happens. This is why I want you to see. It can still be done in the box, but the numbers get big and it gets harder. All right, what's the GCF here? 2x.
Cold.
No, what's the GCF here? Here and here.
Okay, that makes sense when you did that.
Okay, so look, it's 2x minus 5.
Box thing. So I wasn't here to learn.
2x minus 5. Come during lunch, I'll help you. We'll work through it.
What plus 5?
And I put
Well, when the second sign is plus, they both follow the first.
Well, I'm still confused on the PST part. Like, where's
Okay.
the middle coming from? What is the middle issue? I get
The two ends are perfect squares. When you take the square roots of the two ends, okay,
Have to equal what's in the middle.
multiply and double them.
Right, you're right.
Ish.
Now. So you clear the whole board. Right?
Okay. Let me give it to you variable-wise and see if it makes more sense. If these two ends are perfect squares,
Okay, I get that. So
and then if you take the square root of each of those, so the square root of a squared is what? A. The square root of b squared is what? If you double it, whatever this is, or it can be minus,
Yeah, you're gonna nominate me for sugar.
those are perfect square trinomials.
Now.
The square roots of the ends, take the square root and multiply them and double them.
what is the chunk? What is the sign?
It could be either or, either one of these. This is a plus b squared. This is a minus b squared.
So literally, we act
They equal
like,
the same thing.
we act like there's nothing in the middle. I don't.
Well, it's the same. It's factoring. It's breaking it up. Just like here, I could rewrite it out in two pieces like that. If I were to multiply that out, the middle would come back out.
Okay, so like for the next one, it's gonna be 1x. It's gonna be x, and it's gonna be 6.
Right.
So now you're gonna put those two together.
So the question is, does it square dance? If you do square, square, multiply, and double, yes. So that means it is a PST. It does factor easily, and it factors as, and I'm gonna have to write it over here, the square root of the first
This is too much homework.
plus 6. You need me to go to another page? Squared.
No. Keep going. I'll see how much.
Oh, it's going off the board. I see. X squared plus 12x
You did
plus
that for the other one a
36.
while ago, so.
All right, so we said it was. So we take the square root of the first sign, and the square root of the last, and we square it.
And that's the answer.
Yeah.
And we put yes.
No, it just we're still factoring. This is still factoring. It's just a shortcut to factor.
And now if we went back and did the first one, it would show the same thing.
Correct. Do I need to show you?
Nah, I got it.
Can we,
I know
can we like check our work with the box? Like we put it
You can. The problem with that comes in if I give you something like 25 x squared plus 100. 5 times 10 is 50. The bigger they get, if you put that in the box, you'd have to find two things that multiply to 2,500 but add to 100. So it gets bigger and bigger and bigger. It's easy if you can recognize the pattern right off the bat.
Okay, so 5x.
Yes.
5x and then
25
10.
fits into all of those.
5 times 10 is
5 times 10 is 50 times by 2, and it'll be 100. So
So
that's
yes.
your answer is x. It's 5x minus 10 to the 7th power.
well. That was a plus sign.
Oh, and then 5x.
Yes.
Hold on.
All right. Let me show you this one little thing, and I'm done. The reason that we do all this. Okay.
Help us pay our taxes one day.
Do you remember?
Cookie waffles.
Do you remember? And I hope you do, because we just did this Friday. Our retest on it. The quadratic formula.
Yeah.
Okay. Why did we use the quadratic formula?
It's like negative.
Find the answer.
They couldn't, to find the answer to solve for x, we couldn't figure out. Yes, that's the quadratic formula, Gilbert. But look, we used it to solve for x, right?
Yes.
Well, the nice thing, if a quadratic will factor, remember before we could use the quadratic formula, we always made sure that it equaled 0, right?
We're gonna combine all this together.
Same thing.
That's the
All
A.
in one,
That should be.
like be a sandwich.
So we're going to check to see if it's a PST. If it's not a PST, then we're going to have to solve it.
I'm fixing to tell you. Y'all getting so ahead of the game.
Are we gonna be
All right.
that and that?
Watch, I'm gonna show you.
Is that good?
We're gonna make it equal 0. Okay. I'm gonna teach you so many methods that the quadratic formula is gonna be your last method of choice to solve a quadratic.
Yeah, I hate quadratic.
All right. It's messy, that's why. All right. So, to solve this, the first thing I want to do is make sure it equals 0, just like I did with the quadratic formula.
What if it don't say 0?
Then you need to move the stuff just like you did with quadratic formula.
Yeah.
Subtract it from the other side to get everything on the same side. All right. The next thing I want to do is factor. Okay. Now, I just taught you 2 little tricks to factoring, and so Tyler said, so now that means we need to check for, and you're absolutely right, okay? You should go through the process of check for a GCF, check for a special pattern, meaning perfect square trinomial, difference of 2 squares, okay? And then if that doesn't work, put it in the box. So nothing new yet, okay? It already equals 0, but if I need to factor that, is there a GCF? No. Is it a special pattern? No. Well, it's not a difference of 2 squares because there's 3 terms. The ends, 6 is not a perfect square, so it's not a PST. So I'm going to have to put it in the box.
Process of elimination.
X squared and 6. This is the same. We've been using this trinomial quite a bit. What multiplies to 6 but adds to 5? 2 and 3. What's the GCF here? And I'm running through factoring a little bit fast here because that's not what I want to focus on at this point. Well, this doesn't have anything in front. It's just 1. So the biggest thing to divide 1 and 2 by would be 1. How about here?
3.
And here?
1x.
And here?
Was that 12?
No, that's a 2. All right, so factored, this trinomial, oh, why does it do that? This trinomial now looks like x plus 3, x plus 2. All right, here's the only new part, and I want you to think about it with me for just a minute. Do you agree that I've got 2 things that are being multiplied together right there? Do you see that? The 2 sets of parentheses? Do you agree that when I multiply those 2 things together, they equal 0? So I want you to extrapolate a little bit here. Think outside. Bring your outside knowledge and apply it in here.
Outside the box.
Outside the box. If you're multiplying two things together and you get 0 when you multiply them, what has to be true?
0.
What?
0.
Not x, but... Alright, I've got two things. Don't look at this problem. I've got two things that are multiplying together and they equal 0. What has to be true about one or both of those things?
They are 0.
One of them has to be 0. The only way to get 0 when you multiply is if you start with 0, right? So would you then agree that this must equal 0 or this must equal 0? That's how you solve it when it's factored. You set each piece to 0. That's your third step. Set each piece to 0.
Wait, so this is what we have to do.
This is the extra part tonight. The yellow is the new part. You set each piece equal to 0 and solve. So here I would do what? How do you solve the first one for x? Minus 3. How do you solve the second one? Remember when you did quadratic formula and y'all got so mad at me because I made you split it up so you could see the two answers? I made you split the plus and the minus up. Here's your two answers you would get if you plugged into the quadratic formula.
No way.
Yeah! You want me to show you?
No. Gosh, yes.
Yes.
Okay, so.
If we already know what's going
Yeah. Yeah.
Are they perfect? No,
All right.
It's not a perfect.
Your directions say factor and solve. So I want you to, we're going to work through those 3 steps that I gave you. And we're going to factor
Can I use
and solve. Yes, you may. All right.
Not a perfect trinomial.
Well,
GCF.
first step is GCF. Well, actually, first step is to make sure it equals what? 0. So check for step 1, yes?
Yeah.
GCF, does it have one?
No.
No. Step 2. Special patterns. Is it a special pattern?
No.
No.
So we have to go to the box.
So we have to go to the box. Okay. Box.
Over here.
It's cold.
Y'all, stop whining. All right, the signs are mixed. The signs are mixed, yes?
So it'd be negative.
Multiply the two together. Yes, you can. You can. A couple other people do.
So negative 37.
Give me the two terms. I know y'all are getting restless. This has been a long lesson. 10 and 3, which one's negative?
I would have never knew that. The 3.
The 3. Good job, Lexi.
You go, girl.
Why? Okay, wait. Somebody said they never would have known that. Look, if you don't know, what I always do when I don't know is I start listing all the factors there. And then seeing what happens when I add them, okay?
List all the factors.
1 times 30, 5 times 6, 10 times 3. And then which one of those would add up to the 7, okay? All right. Up and over. GCF here. 5. Here. Look again. -1. Take the negative with it. How about here? Yes. 3x. And, well, I'm going to do positive because only one's negative. Do y'all see, do you see why that one was 3x and not 1x? Okay.
No, I want to know what I want to see it.
Because 15, 3 goes into 15 5 times.
Oh, I thought that was a 5, my bad.
5x minus
Oh, yeah. All right. So this factors is 5x minus 1, 3x plus 2. Remember, it still equals 0, yes?
Yeah.
So what's my last step? Because I need to solve.
It would be the.
Set each piece up and solve.
Split each piece up and solve. This one's a two-step equation. See why we spent some time solving equations at the
Why are
beginning?
we doing it like this? Why does it have to make it equal 0 now?
Because we're trying to solve for x, so I get it kind of chunked up so that I can set each chunk equal to 0.
So you put a +1 on the 0.
Plus 1.
It's gonna be 0, 5x equals 0.
No, what's 0 plus 1?
1, I meant my bad.
And then,
So it's gonna be a
You divide by
Yes.
5, and it's gonna be x equals, yeah, you know.
leave it like that. I'm not asking you to do anything else with it. Leave it like that. How about the second one?
It's gonna be -2 over 3.
-2.
I gotta ask you something when you get done with this problem.
Okay.
Miss McGee,
Trey.
Yep.
All right, look. You're good. This one, it's very, very important. You're following your steps as you do this.
Yeah, you still haven't answered my question.
All right. Is this a relevant math question?
No.
Okay, then hold
Hey,
it.
Miss McGee,
Okay.
I ain't sure whether math because it's the same thing, you just got N.
You gotta add the x. You just got 0.
Does it equal 0?
Yep.
Yes.
Yes. Step 2. Factor it.
Yep.
My steps to factoring
Hold on.
say step 1. Okay.
You got.
Miss McGee, you gotta do your talk.
It's plus 0. You add a 0, you add a...
You can simplify it down, right?
Well, that's what I'm doing. What's your first step of factoring? Checking for a what?
GCF.
A GCF.
5.
Trey's trying to tell us 5 as hard as he can. He's absolutely right, but not just 5. 5n or 5x, 5n, whatever the variable. All right. When you take this out, tell me what is left.
Well, you got 9 in, Miss McGee.
You got 9n.
And then you got 2.
Yeah.
Wait, it wouldn't be 9 squared?
Equals 0.
You took an
You take
n
out
away
an
from it.
n.
All right. Shh. Guys, this is the new stuff. I need your attention, okay? It's not new, but this is a little bit different. And this is probably the easiest one to factor and solve, but everybody gets stumped. Do you agree that at the point I am now, I can't factor anything else?
Yep.
Okay. Do you also agree that I am multiplying two things together?
Yep.
Do you also agree that when I multiply two things together to equal 0, one or both of them has to be 0?
Yep.
Then 5n must be 0,
Yep.
or 9n plus 2 must be 0.
Yep.
Just because it's in front doesn't mean you can't set it equal to 0.
Nope.
Okay? Because it's not a plus or minus thing.
Yep.
So when I divide by 5,
You get N.
Get 0.
there's one answer.
Yep.
How do you solve the other?
Subtract 2. It'd be 9. N equals -2 divided by 9. And so it will be N9 equals 2 over -2 over 9. You can't, because 2 can't go into 9 even.
What are you talking about?
He's solving the problem.
So can I